everybody. My name is Collin Ng, and in my Choose Your Own Adventure lab, I decided to find the mu coefficient between my bike and the floor. So, yeah, my purpose is to find the mu for my bike tires, and my physics principles that I used is the equilibrium principle, the formula for friction, and the formula for Fnet. My preview is that mu ended up being around 0.88. So my main physics principles in more detail. Over here is my formula for friction, and then how I set up my equilibrium, even though I was technically not in equilibrium, but that's okay. I took account of that later. So I rearranged F net y over here just to be n is equal to mg, and then I plug the n here into F net. So F net is actually just dp dt times 1 over mg, and then I split up momentum and canceled out my masses. And then I had delta v over delta t times g is equal to mu. So here is my video. My system is me and my bike. My surroundings are earth and the floor. My initial, and I guess technically my brakes too, because it was applying a force to my system. And my initial condition is I was going around this fast. And I actually left a mark on the floor too. There's two here because it's my second attempt at it. Yeah. Anyway, so next up is my data. Oops, please. There we go. A data from my tracker code. So over here is the different timestamps, and then this was my velocity over all of them. So I took this velocity in all the different times, which is like taking the integral. So I pretty much had inconsistent forces, but tracked them all differently. So I assigned my variables to what they were supposed to be. Delta t, the difference between all of these is 0.033. And then I did some math, and then I printed out what my delta v divided by my delta tg ended up being, and that's what you see over here in this far right column. And then I took all of these mu's, and then I found the average of them, and my bikes and the mu, my bike and the concrete's mu ended up being around 0.8, which is quite interesting. So, some mistakes. I assumed that my system was kind of just a big square, even though there were technically two wheels, and one of them was still spinning for a little bit, because I only squeezed my back brakes. So there could have been a lot of errors with my understanding of physics within the original problem, but I feel like I still came to a strong conclusion. Some other problems might have been the concrete might have been just a little bit wet because it was cloudy that day, and the wind might have been blowing because, once again, the weather. And I'm not 100% sure that I did the constant force part right, but I think I might have, so I just put it on here just to be safe. Well, that is the end of my presentation. Thank you for watching, and I hope you have a wonderful day.